Welcome back to your differential calculus. Okay, so we will proceed to your module 2, wherein we will now be starting with the derivative or differential itself. Okay, so this includes your module 2. You have here your unit 1 to 7. Okay, so we will first discuss how this derivative function is derived. And then let's go to slope, how derivative is related to slope. And then we will go on with properties or formulas of differentiation. And then other formulas. These are other formulas or concepts. Okay, chain rule, inverse function rule, higher derivatives, and implicit differentiation. Okay, so let's start with the derivative of a function. Okay, so what is the derivative of the function? Okay, so before anything else, let's start with this so-called symbol delta. Okay, this triangle looks like a triangle. Okay, it is red delta. This is a big letter delta in your Greek letters. Okay, so the meaning of that is change or increment. So if I will pair that delta sign with any variable, then it would be read, okay, I will pair it with x, then it would be read change of x, or you can call it increment of x. Okay, so again, if delta is paired, that means that is change of the variable. Then, okay, this delta x now will become one variable which is different from the variable itself. So let's start with your function. Okay, y is a function of x. Y equals f of x. So what is the meaning of that? Okay, let's say since y depends on the value of x, okay, let's say I will add a change or an increment of x. Then what will happen with y? Since again, y depends on the values of x. So if I will I will add a change on x, then that will create a change in y. Okay? Again, it will reflect a change in y. So that is delta y also, or a change in y. Okay? So if I will try to transfer this y on the other side of equal sign, it will become minus y. That is a rule of algebra. Then you will have this delta y equation as this side equal to this right side. Then if I will continue, okay, as you can see, this is variable y, so on the other side I want to make it a single variable, x only. However, I transferred there your y. But if I will go back to the original equation, y is equivalent to the function of x. So I will substitute that one so that everything here on the right side will be variable x. So variable y, variable x. Okay? And then I want to get the ratio of the change in y with respect to change in x. So what will I do? I will divide both sides. What will I do on the other side? I should do that also on the other, because that is rule of mathematics. What you did on the other side of equal sign, you should also do that one on the other side. Okay, so I divided, okay, because I want to get the ratio of delta y over delta x. Then I will also divide the other side by delta x. We call this one as the rate of change of y with respect to x. Okay, so it is a ratio of the change of y because of the change in x. So we call that one rate of change of y with respect to x. WRT stands for with respect to. Okay. Where will I use this one? Okay, where will I use this one? If I will get this rate of change of y with respect to x, and I will now focus on my variable. Okay, again, as I told you a while ago, a delta x is now a different variable compared to x. So this is now a different variable. So let's say I will focus on that delta x, and then I will minimize. If we say minimize, I will approach 0. Again, approach means not equal. Okay, so it means I will be very, very close to 0. It means that is a very, very small number. Okay, So I will minimize the value of that delta x. It means I will be considering only a very, very small change in x to the function of this rate of change. Okay, I will approach or I will minimize delta x to this function. And what is the equivalent of that? That is the small dy dx, or that is what we call the derivative. That is now what we are talking about here as the derivative. Okay, so that is now the derivative of y with respect to x. Please do not interchange this one, okay? Big letter delta y, delta x. By the way, delta, actually that is supposed to be small letter delta also, but the small letter delta looks like d. That's why it is simplified by writing d, small letter d. The only difference of this is that in delta y, big letter delta y, that means that is a big change. But since we minimize the change, then we are considering a small change in derivative. Okay, so again, derivative is a small change in y with respect to small change in x. So that means there is a small change in y because of the small change in x. Okay, so that is the derivative that we are talking about. Actually, this one, I could rewrite this one into this form. That means the same. But y is your function. So, d over dx stands for derivative of y. Okay? With respect to x. Derivative of y with respect to x. That is the meaning of this d over dx. Derivative with respect to x. So, let's say, I am not talking about y this time. Let's say that is a different variable. Let's say that is t. Then, derivative of t with respect to x. Derivative of t with respect to x. That is the meaning of that. Okay? And what is this? That is actually still the derivative, but we have here its other form. Okay, there are a lot of ways for us to write that one since there are a lot of books. So they use different signification for derivative. This is the common, of course, dy dx, but that could be written as f prime of x. Prime stands for derivative. F of x is a function. So f prime of x is derivative of the function x. That is the meaning of that. The prime stands for derivative. And you could also write that since f of x is equal to y, you could also write that one as y prime. It means derivative of function y, which is equal to f of x still. Or the others, okay, since there are a lot again of books which are using different notation, the other wrote this way. D stands for derivative, y, that is a function. Since x there is a subscript, that means with respect to x. Okay, so let's say they will interchange. Y is the subscript and then x is there. So it means derivative of x with respect to y. Okay, so there are a lot of notations for derivative. But do not be confused. That will still be the same. Okay, so that is derivative of function again. The derivative of function is the ratio of a small change with the variable with respect to the other variable. Okay, so that is derivative. Okay, how do we get that one? How do we evaluate now the derivative? Okay, so this is now an example for us to discuss how we will get a derivative. Actually, it is already presented here in the previous slide. We call this actually as the four-step differentiation. Why four-step? Because you will add a change in your equation, and then uh, I will transfer y on the other side. I will transfer the original function on the other side and simplify that one into a single variable. That is the second step. Third step is to get the rate of change of the variable with respect to the other. And then the last step is get the limit as that small change approaches 0. So we call this one four-step differentiation. Okay, so that is what we will apply in this example. Okay, so find the derivative of y equals x squared. So here is your solution. Step 1. Of course, since again y depends on the values of x, so I will introduce a change in y. I will change y by introducing this delta x. That will now result to a change in y. Okay? Then, just like what happened a while ago, I will transfer y on the other side. But I need to make that one into a single variable, which is x. If I will go back there, y is equal to x squared. So, okay, later on, what is my solution is this way. Before I change y, I will first expand, but it doesn't matter, okay? That is just procedure, but it will be still the same. You can actually substitute directly here your x squared and then simplify that one, or you can do it since I just did it step by step here. Okay, so what I did is that I will expand this. Since this is a binomial, that is algebra, guys, I will expand. So x times x is x squared, x times delta x is x delta x times 2 is 2x delta x. Square your final delta x, that will be delta x squared, and of course that is y. Then now I will change that y into its equivalent x squared, so that everything will be in terms of x. Now simplify further. Before proceeding to the next step, simplify further. Isn't it x squared and negative x squared cancels? Yes. So what's left is just 2x delta x and the quantity delta x squared. But look at this. I can factor out the similarity. There is a delta x and there are two delta x here, so I can bring out one of them. So what's left will be 2x and then one of the delta x. So I can now proceed to the third step, wherein I will get the ratio of delta y delta x by dividing both sides by delta x. So I have here now the delta y delta x, which is the rate of change of y with respect to x. Since I divided this by delta x, that cancels with the one that I factored outside. So we are left now with 2x plus delta x. This is your rate of change. Okay. Now, last step is for us to evaluate or find the derivative that we are looking for. This is the rate of change equation. I will now try to minimize the change in x by approaching 0. It means I will consider again a very, very small number or small change. Then, okay, as we recall a while ago, this is the formula. That is now the dy dx, which is the derivative that we know. Okay, so now I will get the limit, of course, of both sides. If I will get the limit of this, that is your dy dx. So that is your derivative na on this left side. But on the other side, I will of course apply here the limit, since again, if I will do this one, limit of this delta x, delta y over delta x as delta x approach 0 is again dy dx, so that's it. But on the other side, I need to apply the property of limit, or since I explained before in the last video that limit could just be direct substitution as long as there is an answer. Okay, so if I will apply the limit, that will be distributed. Okay, look here, your function is 2x and your variable that we are focusing is delta x, so the limit has nothing to do with 2x because there is no delta x in your function, so that will remain 2x. Now delta x, limit of delta x as delta x approaches 0, so that is your again property in limit, wherein that will just become itself, which is 0. So I do not need to put there 0, therefore dy dx, or the derivative of that function on top, is 2x. Okay, so that is your derivative. That is the answer. Let's have one more example. Okay, so find the derivative of s equals 3t squared minus 4. Okay, so it looks different because of the variable that we are using, but the same procedure and the same process. Okay, so it says there that s depends on t. Okay, so s is a function of t. So here is our solution, the same. Since t is your equation or the variable here where s depends, then I will introduce a change in that t. So I will introduce a change in that t. So that is your delta t. That will result to a change in s, which is your delta s. Again, I will transfer s on the other side, and okay, that's it. I will transfer s. Then I will of course simplify this one. I will expand, so 3 will still be outside. I will expand this one, and that is the result, just like what happened here. Okay, and do not forget there is minus 4 and still s is there. Now, if I want to simplify, since t is the variable here and there is an s, I can go back to itself, to its value on top, which is 3t squared minus 4. So that will be substituted there. Okay, be careful because there are more than one term, so you need to put their grouping sign, especially that is minus, so that will affect the signs. Okay, now I can at the same time distribute this one, so that will become 3t squared. Okay, that will become 6. That will become 3 delta t squared. And now negative 4, and of course the value of s. Okay. If I will now distribute this negative, that will become negative 3t squared. It will cancel with positive 3t squared, right? Okay. And then I will distribute that negative with negative 4. That will become plus 4. And that is a minus 4. That will also cancel. So what's left are only these two terms. Now what will I do? Just like what I did a while ago, I will factor out, bring outside the similarity. Bring outside the similarity. So in numbers, there is a similarity as 3. So I will bring out 3. And there is a similarity which is delta t and 1 delta t. So I will bring that out. So what will be left here is 2 and t, since delta t is already there. And then what will be left is 1 of the delta t. Now, I will divide both sides by delta t, so that I will get the rate of change. Now, if I will do that, delta t and that delta t here will cancel. So your rate of change equation is now just 3 times 2t, the quantity 2t plus delta t. Okay, we are not done yet. That is just the rate of change. That is just the rate of change. Again, I will get the limit of both sides, and the limit of that rate of change is your derivative. So, if I will get the limit of this left side, that is your derivative, and I will get the limit of the other side. So again, 3 is just a constant. That is rule of limit. That will just go outside. This will just be distributed. So limit again. Your variable that we will try to approach to 0 is your delta t. So it has nothing to do with 2 and t. So nothing happens with that. That will still be 2 and t. But a limit again of delta t as that delta t approaches 0 is 0. Okay? So I do not need to write that. So if I will now simplify, the final answer for your derivative is 6t. Okay? So that is how we will get the derivative. But this is what we call as the 4-step process. This is how it is derived. Because later on, if you had already your pre-calc and basic calc in your senior high, you already have the formulas. And these formulas are actually derived from this 4-step. So it just made our life easier because of those formulas. But again, if you forgot about those formulas, you can still go back to your 4-step differentiation, and then you will still end up the same. Don't worry, using the formulas later on, let's try to evaluate again the derivative of these two functions. That should be the same. Okay? Now, let's try to understand this slope. How is it related to your derivative? Okay? So let's focus first on the drawing. Okay? Focus on this red drawing here, red curve. That is the drawing of your function y equals f of x. Okay, if I will consider here a point on the function, let's say that is point P. So we do not know that is any point. So let's say that is P. That we do not know the coordinates x and y. So that is just P with coordinate x and y. Let's consider that point. And then if I will again, okay, this is what this is the graphical explanation of that delta y delta x. Okay. If I will now try, okay, your x is the x coordinate. If I will add a change in x or a delta x, okay, I will add a change in the x, then that is your delta x. So let's say I will add, so that will go here. Because of the change in x, the point should stay on the curve because we are talking about the function. Okay? Because of the change in x, there will be a corresponding change in y, which is this, delta y. So that your point will still be on the function. Okay? So again, this is your point. I will try to add a change in x that will result to a change in y, so there is a movement on the point. Now, if I will connect these 2 points, let's say P1, okay, so the coordinate of this is x and the change in x, y and the change in y. Okay, so let's say that is P sub 1, so to differentiate with your P here. If I will connect these 2 points, that is your green line, this green line here. Okay, so that is a line passing through points P and P1 having a slope of delta y, delta x. Okay, so now how is it related to slope? If we say slope, that is the degree of sharpness of a line, right? The slope is the degree of sharpness, how sharp or smooth the line is. We are talking about the inclination. So how is that? In your geometry before, slope is actually, okay, slope is tangent theta. Tama? We say tangent theta, we can refer to a triangle. That's why I created here, okay, actually there's already here a right triangle because of that delta x, delta y. Delta x is horizontal and delta y is vertical since we are talking here of x and y movement. Now, since that is horizontal and vertical, then that creates a 90 degrees. So this is just a right triangle. Okay. If we say slope, okay, we will consider the angle from the horizontal. So that, let's say that is theta. So according to your geometry before, slope, that is corresponding to m. We are using m to signify your slope. Okay, so m or slope is just the tangent of the angle from horizontal. And if you say tangent, this is it in your trigo, that is just opposite over adjacent. If you say opposite, that is the front of the angle, and then the leg that is paired with your or connected to the angle. Opposite over adjacent. So that is just delta y, delta x. And as I've told you a while ago, isn't it that delta y, delta x is the same as dy, dx, or the derivative that we are talking about. Why? Because this is the same ratio as this. However, we just consider a small change. That is your derivative. If we will just consider a small change in this delta y, delta x, that is your derivative. Okay? So now, the explanation of that. In this original line, green, the green one, there are big changes in delta y, delta x. So there is a big movement in your point. But if I will just consider a small change, very, very small change in delta x, then maybe the movement will just be just after this point. So, sorry, it is very, very close to the original point. Then, of course, that will result to delta y, but still very, very small. So, instead of the point to be here, that is very, very close to your original point. So, it seems like they are only one point. So, if I will connect that, then this is just the line now that is passing to those 2 points. But it looks like it is just passing at a single point. So we can neglect these 2 points. We can say that it's just single point. Okay? So if I will draw this line, then that is just a tangent line. Why? Because it only passes at one point. That is your explanation of tangent line in algebra. Right? Okay, tangent line. A line that passes on a curve at a single point. Okay. So again, that is the explanation how that delta x, delta y became derivative, which is dy dx. I considered only a small movement in delta x and a small movement in delta y. Therefore, it seems like there is no movement at all. So if I will connect these 2 points, it seems like the line connecting is just passing at a single point. So, that is just the line whose slope is dy dx. So what is dy dx? That is derivative. Okay, so we call that one tangent line at point P. Therefore, you can say that the derivative, okay, that's why this is colored blue because this is important. The derivative of any function, okay, we are talking about the derivative of any function. So let's say that is a curve. Derivative of any function is just the slope of its tangent line at any point. Why? Again, let's go back. The derivative, isn't it? This is your derivative. Is just the slope of the tangent line on that point that we are considering. So let's say we will consider different points here. That will still be the same, that derivative. But since you are passing on a different point, you will substitute that in the equation, then that will be different value. But still, the derivative is the slope of the tangent line. Okay? Derivative of any function is just the slope of its tangent line at any point. Okay? So y prime, or that is dy dx, is just slope of your tangent line. Okay, so that is how slope related to derivative. Okay, so this is now the properties of the formulas that I am talking about. So just like in limits, we have properties of limits. So we have also properties of differentiation. It will just make our work easier. Okay. So before I'll proceed, let's again familiarize ourselves with this. We already discussed this one before, but let's say again, familiarize ourselves. C is corresponding to constant, that is just a number. In these properties, we are also using u and v. So this is just a function of x, or let's say we are having an equation of t, then that is a function of t. So c is constant and u and v are functions. They are different functions. Okay. So let's start with the first property. Okay, again, this d over dx means derivative of this function with respect to x. That is the meaning of that. So derivative of any constant with respect to x will always be 0, or derivative of any constant is always 0. Now, derivative of x with respect to itself, that is the meaning of this. So that will become dx over dx. So it will cancel, that is 1. Okay, again, derivative of a variable with respect to itself is 1. The third, we call this number 1 as constant rule because of that constant. Okay. Third rule, or third property, if you have there, again, what is c? Constant, and multiplied to a function. U is a function. That could be a complicated or a simple one, as long as that is function. Then c, since c there is just a number, I can bring that outside, just like in limit. I can bring that outside and then get the derivative of u. So that will be du dx. So again, if there's a multiplier constant c, I can just bring that outside, factor outside, deal with the derivative of your function u. And then fourth one, we call this one the sum rule. Could be sum plus or minus, but generally called as sum rule. Okay. If you have two different functions added or subtracted together, just like limit, you can just go inside, distribute your derivative. So you will have derivative of u plus derivative of v. Product rule. Okay, this is now a little bit different with your limit. In limit, you will just get the limit of the two functions and then multiply. But in differentiation, this is very different. Okay, it is now said that if you are differentiating or getting the derivative of two functions multiplied together, it says there that copy the first one or copy the other and then differentiate the other. Copy the first one and differentiate the other. And then plus reverse the process. The one that you differentiated, which is v, that is what you will now be copying, and then differentiate the u that you just copied a while ago. So this is just u dv, v du. Okay, so they are interchangeable. You can interchange this, no problem, since that is just plus. Again, copy, differentiate, plus copy the other one now and then differentiate the other. Okay. How about this one? This is in the form of division, so that is quotient rule. a function is divided by a different function. How to evaluate the derivative of this? Again, it is very different from limit. Copy the bottom, differentiate the top. Minus, okay, minus. This is now minus this time, not plus, unlike here. Again, copy the bottom, differentiate the top. Minus, copy now the top, differentiate the bottom. And then all over the square of your bottom. Okay, we have just like a familiar familiar phrase for this. You can call u as your high and the v there as your low. So low the high minus high the low over low squared, or low the high minus high the low over low, since this is 2 v's. It's up to you how you will memorize. Again, let's say u is my high and v is my low, means high part, low part. So low the high minus high the low over low. Okay, so it's up to you. That is quotient rule. Okay, then lastly, power rule, or we call this one the power formula. Okay, so you have now a function and you have exponent. So n there is any number that is still a constant, that is just a constant. N is a number, exponent. So how we will evaluate the derivative of this is, okay, this is your formula. N will go down, copy u, and subtract 1 with your exponent, and multiply the derivative of the u itself. Okay, that is power rule. This is a formula, so we are just following this one, so that we will not be doing the 4-step differentiation. Why? Because if we will be having a very complicated equation and we are doing that 4-step differentiation, it will take us a lot of time, and that will be a very long solution. Okay, so it is not advisable for you to be applying your 4-step differentiation, but it is still applicable. Okay, the same answer. However, it will be a very long. That's why we have here the simplified properties. We will just follow, and that will give us the derivative. Okay, again, your power rule. The exponent will go down, copy the function, subtract 1 with the exponent, and then differentiate the function itself. Okay, let's have an example for that. Okay, that is the example that we solved in the 4-step a while ago, right? We added delta y, delta x, and then we get the limit. So why not just apply? Let's try to verify that one. If your properties are correct, that should be the same. Okay. Okay. So I will differentiate again d over dx. It means differentiate with respect to x. Why? Because in this side, that is x. Okay, the variable where y depends is x. Therefore, we are differentiating with respect to x. But let's say that is a different variable, then that will be the variable that we are differentiating with respect to. Okay, so differentiate both sides. What you did on the other side, you will do that on the other side. Rule always of algebra. So if I will differentiate y with respect to x, then that is just your dy dx, which is your derivative. Okay, but in this side, on the right side, derivative of x squared with respect to x, what is the meaning of that? What property are we going to apply? We will go back here. Of course, the obvious there is that the one with exponent. Function. Your function is x. Right? Your function is x. It is a simple equation, which is x only. And your n there is 2. Your n there is 2. So what did the power formula suggest? I will now differentiate, apply the differentiation so that will be gone. Okay, I already applied here, that's why it is already there, which is your derivative. I will now apply, so that will be gone. I will apply. 2 will go down. Copy your function, which is x, subtract 1 in your exponent, And do not forget to differentiate your function, which is x. That is the meaning of your du dx here. Okay, that is the meaning of that. Bring down, copy, subtract, and differentiate the function u. Okay, again, 2 will go down, copy x, subtract 1, and differentiate again your function, which is x. Okay, we are not done yet because of this, so we will still proceed. Just like in limit, if limit is still there, you need to proceed, and then so that there will be no limit at all. So there is still a differentiation here, so we will still proceed. If I will differentiate x, what is that? That is your rule number 2. Derivative of a variable with respect to itself is 1. Okay, therefore, d over dx of x is just 1. So, I can now say, what is 2 minus 1? Of course, that is 1, so that will just be 2x. 1 times 2 is still 2. 2 minus 1 is 1. So, that is your dy dx, that is your derivative. Or since, again, dy dx could be written as y prime, since y prime is the simplest way to write that one, why not use y prime? Isn't it? That is our answer a while ago. We will go back, okay. Dy dx, or that is just y prime, 2x. Let's go to our example a while ago. The answer is 2x. So, yes, it is correct. The differentiation property is correct. Now, we will be solving this one as our second example. The answer should be 60. Memorize that one, please. So that we will proceed now to the applying the properties. Okay, so let's go to the second example. That should be, again, the answer should be 60. Now, just like what we did here, differentiate both sides, okay? So if I will differentiate, that your variable now here is s depending on t. So we will differentiate with respect to t, okay, both sides. I will differentiate s with respect to t, that is your ds dt, which is the derivative of s, okay? Or you can just write it as s prime, it doesn't matter, it's up to you. If it is easier for you to write this, then no problem. But it is, of course, easier for us to write s prime, so it's up to you. So again, the derivative of s with respect to t, let's say ds dt or s prime. On the other side, that is our problem since it is a little bit complicated. So this is your property sum rule. You can just distribute, right? That is a plus or minus. Distribute. If I will distribute, then I will deal with this. This is what? Okay? That is your property number 3. If you will go to number 3, there is a number multiplied with your function. So what will happen? The number will just go out, deal with the function. Now, how about this negative 4 here, or 4? The derivative of any number is 0. So that is useless, 0. Okay, so we still have yet to apply here the power rule. T is your function, 2 is your n. So, 2 will go down, copy t, subtract 1, and then differentiate the function, which is t. Again, just like what happened, derivative of t with respect to itself is 1. So, 2 minus 1 is still 1. So, 2 times 3 will be 60. Times 1 will still be 60. So, this is our answer in your 4-step differentiation. So, you can say that is ds dt, or you can just say s prime. That means derivative. Okay? Oh, that is your answer. Now, since you already have your property, of course, unless you want to go back to 4-step differentiation, it's up to you. But again, why make your life complicated if there is an easier way? Okay, so let's have more examples. Okay, how about this? Derivative of y equals square root of this function. Okay, so the same. Differentiate both sides. But of course, there is no property such as square root. But just like in limit, square root or any roots could be transformed into exponent. So I did not yet apply differentiation. I just transformed that one into exponent so that you will see what happened. Now, if I will differentiate both sides, derivative, again, with respect to x of y, automatically that is your derivative, or y prime. I use here y prime, that is easier for me to write. Then in the other side, if I will differentiate this one, what property? That is power. Why? There is an exponent, which is 1/2, and this is your function. Okay, your function now is a little bit complicated. Unlike a while ago that your function is just x, and that is just t. But this time, it is more than one term, but it is still your function. Why? Because everything is raised to 1/2. So we will just follow the property of power. So according to power, bring down this exponent. So I put there 1/2, I bring down. I will copy the function. So I will copy totally that function. And then I will subtract 1 with your exponent. Okay, so originally that is 1/2. I will subtract 1 from 1/2. That will be negative 1/2. You can calculate that one with your calculator if you do not believe me. Okay. So again, bring down 1/2. Copy the function. So that is this. Subtract 1 with your exponent. So that is negative 1/2. And do not forget, always differentiate the function. So I will now be differentiating again the function. A while ago, this is just x, this is just t, so that is 1. But this time, it is now some rule. So we will again apply some rule. Okay. So just bring down this one since nothing will happen there, but we will evaluate the derivative of this. As you can see, some rule, so I will distribute. But if I will distribute there to 2, what is the derivative of 2? That is 0 because it is constant. If I will put that to 3x, 3 will go out. And I will differentiate x, which is 1. So, the derivative of all of these with respect to x is just 3. That is the 3 here. Okay. Now, I will simplify. Since 3 is just a number, I can combine that with this number. 1/2 is also just a number. So 3 times 1/2, that will just be 3 over 2 or 3/2. Copy, of course, that one. This could be your answer actually, but why not simplify? We can play with the equation, that is algebra. You can always play so that it will look a little bit approachable. Okay, I mean not approachable. It will look more, however you call it. But for me, this looks nicer compared to that one. Okay. So how did it happen? Okay, this is just an algebra. You have there a function raised to a negative exponent. So for that to become positive, that will go below your bar. We did that one before on limit. So what will be left on top? Since this, for that to become positive, that will go below on the denominator. What will be left on top will just be 3. So 2 is multiplied to this, and your exponent will become now positive. And then, I do not want also a fraction exponent. I do not want an exponent which is fraction. What is 1/2 as exponent? That is square root. Okay, just like what happened here. I just reversed. Square root is 1/2. Now, 1/2 I will bring it back to square root. So the answer is this one. Okay, that is number 3. Let's have one more. Let's have this as your final example. Okay, so find the derivative of this function. Okay, so as you can see, okay, so what can you see here? We have here already a bar. We have a bar. So what is the obvious property is, of course, quotient. Quotient. So I will differentiate both sides. So this is your solution. Differentiate y, that will become dy dx or y prime. Differentiate this one, this side, that is quotient rule. There are two solutions here, so I will first, of course, apply the obvious, which is quotient rule. So let's go, before I will proceed, let's go back to your quotient rule. Okay, so according to quotient, copy the bottom, differentiate the top. Minus, copy the top, differentiate the bottom. Over the bottom squared. Okay, so that is what we will apply in your example number 4. Okay, so again, copy the bottom, differentiate the top. So I will differentiate that 4. Minus, that is minus. Okay, do not change that one. That should be always minus. Copy the top. Okay, so that is your 4. Differentiate the bottom, which is this complicated one. And do not forget to square your denominator. Square the denominator. Okay, now I will proceed. Okay, so I will just copy that one. But the derivative of any constant, which is 4, is 0. So that will be useless later on. That's why it is gone in this part. So that will be useless. This is useless because of the derivative of constant, which is 0. Even that is very, very complicated. If you are multiplying it to 0, it will always be 0. Okay, how about this one? Okay, so negative, do not forget there's a negative. Copy 4. If I will differentiate this one, what rule will I follow? Again, you have complicated equation inside, but everything is raised to 3. So power rule. Again, according to power rule, bring down exponent, copy your function, subtract 1, so that will become squared, and then differentiate the function inside. So that is your derivative. If I will differentiate the function inside, 1 will become 0, 2x, the derivative of 2x is 2. So that's it. We are now done with differentiation. All we need to do is simplify. That is useless, right? Yes, because of 0. Do not forget there's a negative, so carry that one. 2, 3, and 4 are just numbers, so I can multiply that one. 2 times 3 is 6, times 4 is 24, so negative 24. And of course, the quantity is squared. If I will square this one, okay, this is your index law in algebra. You are raising a power, so that will just multiply, right? Okay, so that will be 6. But as you can see, there are similarity on top and below. There are 2 of these 2x plus 1, and there are 6 here below. So I can cancel this 2, and then I will minus here 2, so that will be 4. So your answer here is this one. Okay, so that is your derivative. Okay, this is an OR solution or another solution, which you will find a little bit interesting and easier to use. Okay, so we will only apply this one in the case of quotient if the numerator is just a number. Why? Because this will be happening. There will be a useless differentiation. So, since again we can play with this before we will differentiate, this is just algebra. I do not want to have a fraction since that is just a number. Why not put this on top? Right? Yes, I can do that. If I will put this on top, what will happen? That exponent positive 3 will just change sign. It will become negative, just like what happened here. That is negative, but it is going across the bar. If you will go across the bar, what will change is the sign of the exponent. If you will go across the equal sign, the one that will change is the sign. But again, across the bar is your exponent, the sign of exponent. So that is what happened here. So this will go on top, but it will become negative 3. Okay. So it looks simpler than this, right? Yes, of course. But the question, what property will I follow if I will differentiate both sides? Then that is just 4 is just a number, right? Yes, so that will just go outside. Now, if I will differentiate this 2x plus 1 raised to negative 3, that is power rule, right? Yes. So, 4 will just be there as in 4, or you can put it here outside. Now, differentiate. Power rule. Exponent will go down, so negative 3 will go down. It will multiply with 4, which will become negative 12. Copy the function. Your function is 2x plus 1. So I will copy 2x plus 1. Subtract 1 with negative 3. So that is negative 4. Do not forget to differentiate inside, which is differential again of 1 is 0. Differential of 2x is 2. Therefore, I will simplify further. 2 times negative 12 is negative 24. Negative 4 is the exponent, so that will go again across the bar so that it will become positive. which is exactly the same as this. Okay, that is another solution for number 4. Okay. Okay, so try this one on your own. Okay, so try this one in your own. What can you see here? This is function, yes? You can say this is u. And that is multiplied with another different function. Let's say this is v. So that is u times v. This is product rule. So please do that in your own. Follow your product rule a while ago. What did product rule states? Copy, differentiate, plus copy, differentiate. Okay, then simplify. The answer should be this. Okay, I will discuss the solution of this next meeting. Okay, so we just like last meeting, we will be having an online discussion. At the same time, question and answer if you have something that you did not understand in this video. So if you have question in this previous video, in this previous slides, comment below so that I will prepare for that before we will go to your the discussion of this example. Okay, so that will be our question and answer next meeting. Okay, so please do that in your own. Again, you will not know if you know how to differentiate if you will not try. This is a mathematics subject, so you will not know if you know unless you try. And actually, the best way for you to learn in a mathematics is always solving, practicing. That is mathematics. No memorizing. Do not just memorize answers because, of course, we have a lot of problems. Unlike in history that what is your national hero? Just memorize that. That is Jose Melchizedek. I mean Jose Rizal. Okay. So try this one. Thanks. So see you next meeting for the discussion.